So here's the question. Which modeled listener variant best matches the observed pronoun interpretation behavior that we see from children and adults? Well, something that's important to keep in mind is that model variants with more parameters will have an easier time fitting the data because they have more degrees of freedom. So just to recap on how many parameters we're talking about, our baseline model, which is just straight Bayesian inference, has accurate representations of information from the input and accurate deployment, that is always using all the information, so there are 0 free parameters, right? This contrasts with the modeled variant with an accurate representation that has contrast parameter sigma for 4 different information bits, 4 free parameters. And then our inaccurate deployment variant also has 4 free parameters, use parameters beta for, again, those same pieces of information. And then our inaccurate both variant, of course, has 8 free parameters, our sigmas for our contrast and our betas for our use, so a lot more. So what we're looking for really is that variants with more parameters need to have a substantially better fit in order to favor them over variants with fewer parameters. So with 0 parameters, a certain amount of fit, but to favor ones that have 4, we want substantially better, and to favor the one with 8, we want like a lot better, right? To balance out the number of degrees of freedom. So the Bayesian information criterion, BIC for short, is one way to quantify this preference. And this is the implementation of it. It's the number of parameters times these other things, subtracted that other bit. And the idea is it ranges from 0 to infinity, where closer to 0 is better, and I'll show you just the intuition of that in a moment. So the number of parameters matters, so more parameters gives you a higher score, further from 0, therefore closer to 0, fewer parameters is better. You also multiply that by just the log of the size of the data set, just to sort of get a sense of like how much data are you trying to capture. But the other piece that's important is model fit, right? This is how well you're able to capture the data, and we're going to be using the likelihood of the data given the model variant, the best fitting parameter values that it's able to find, right, is our estimation of model fit. And the log likelihood, this here in this case, ranges from negative infinity to 0, where closer to 0 is better. So in both cases, like closer to 0 is better, which is why overall for the BIC, closer to 0 is better.